today's session of some important derivations from electromagnetic field theory. And this is the third session on this topic. Already I have discussed some important derivations for the intensity calculation for the different conditions, potential calculation for the different conditions, and we have also discussed the Laplace and Poisson's equation. Then we have discussed about the different types of conditions for the wave transmission for the lossless conductor, free space, like this. Myself, Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department in IARE. Today I will discuss some more important derivations for the electromagnetic field theory 3. So first we will discuss the capacitance of a parallel capacitor. So this is a very easy and very first one is very easy. We are taking some two parallel capacitance and in between there are some dielectrics epsilon not epsilon r, or in one word we can write epsilon. The cross-sectional area of the each one we are taking as A, and distance between them we are taking as D. The distance between the two parallel plates we have taken as D. We have connected this with an external voltage source. What will happen when it is connected to the electric voltage source? There will be some flux, and flux means, and according to the Gauss law, we know number of electric flux is equal to, we are getting from the Gauss law that the number of electric flux psi is equal to charge enclosed. So if we take the total charge enclosed into the two parallel plate capacitor, if we connect the source here, if the one is induced, if one plate is induced in the positive charge, if one positive charge is accumulated once, then negative charge will be accumulated in the another plate. So if the total charge is Q, so we can write psi is equal to Q. So what is the electric flux density? Electric flux density is equal to Q by A. A is the cross section, the surface area of each plate. So what is D? We know D is equal to epsilon into E. What is epsilon? Epsilon is nothing but the permittivity. Epsilon is nothing but the permittivity of the dielectric medium. So we got that E is equal to Q epsilon into A. Now what is voltage? We know the relation voltage is equal to, we are taking only the magnitude, not the direction. So voltage is equal to E into D. What is this? E is the electric field intensity is equal to distance. V is equal to E into D. So V equals to Q D by, in the place of E, we are writing Q by epsilon into A. Now what is the capacitance? Capacitance C is equal to Q by V. If where the source voltage is V, we can write Q by V. So Q value we know, Q by V. V value we got here. So we will get C is equal to epsilon A into D. And for the free space, this value will come epsilon A by D, or the value of the epsilon naught is equal to 8.854 into 10 to the power minus 12. Now we will discuss about the capacitance of the parallel plate capacitor with composite material. What is the meaning of the composite material? Composite material means there are two parallel plates like the before, whose cross-sectional area is D and distance between them is small d. Now we are keeping two material. here. This is the one material whose strength is D1, and we also kept another thing whose capacitance is D2. So we take the two materials D1 and D2. So similarly, what is capital D1? Capital D1 flux density for the first dielectric, capital D1 flux density is Q by A. One thing, as we are connecting the capacitor with the same potential V, so same charge will be accumulated on the both both plates. So D1 is equal to Q by A. Both our cross-sectional area is A. So epsilon E1 is equal to A. So from here we got C, or we can tell C1 is equal to epsilon 1A by D1. So again we are connecting the same potential. So for the second case, so what will happen in the second case? For the second case, again D2 is Q by A. So epsilon A2 is equal to Q by A. E2 is equal to Q by epsilon 2 by A, because E2 is equal to, we are just dividing it. So V2 is in the second case E2 D2. So we are again getting the capacitance is equal to epsilon 2A by D2. So this is the second case. We got the two case. Now, as the two case, you can see they are connected with the two different potential. We can assume that the both are connected in the total capacitance C1 is C is equal to C1 plus C2. So epsilon A by D1 plus epsilon 2 by D2. Or we can write A by D1 by epsilon 1 plus A by D2 by epsilon 2. Or we can write like this: A epsilon 1 D1 plus epsilon 2 D2. So we can write the equation in the different format. If there are n number of composite materials, like if we're taking the example of an electrical underground cable. So first is the copper conductor on which one impregnated paper. Next is the C. The next one is the polyvinyl coat. So different dielectric is there. So we can write epsilon 1 D1 plus epsilon 2 D2 up to epsilon n by dn. So this is the capacitance for a composite material. Now we will discuss about the capacitance of the isolated sphere. What will happen if the capacitance for an isolated sphere? Isolated sphere means once only we have one circular path, one sphere, and the sphere is grounded. There is only one sphere and the sphere is grounded. This is known as the isolated sphere. So what will happen if we take the isolated sphere? Let us consider an isolated sphere which is positively charged with a radius of x, and negatively charged placed is in a infinite distance. Actually, infinite distance means it is basically connected to the ground, because we cannot infinite distance we cannot melt easily. So what is the electrical flux density of a sphere? We know electrical flux density is equal to, again using the Gauss law, number of flux D is equal to d psi by dA, or psi by A. Psi is the electric flux, and according to the Gauss law, psi is equal to Q. So we can write Q by A. Now what is the Q by A for a sphere? This is a sphere. So for a sphere, the cross-section area is 4 pi x square. So Q by 4 pi x square we got. So what is the electric field intensity? Electric field intensity is actually 4 pi epsilon by x square. So what is the work done? Work done, or we can write what is the D? D is equal to, we can write epsilon into E. So what is the work done? Work done is equal to, we know last class we have discussed, work done to bring one unit charge is equal to minus Q integration of E dl. Integration, actually work done is equal to Q into potential. So what is B? B is nothing but the integration minus of integration E dl. Q not dot cross product, it is actually Q dot B. So we can write W is equal to minus Q. Here distance is from infinity to the x. So E dx and limit is, we are bringing the charge from infinity position to the x position. So it is infinity to x. So what is potential? Potential means what is the potential? W by Q. So we can write V is equal to integration of E dx is equal to infinity by x. So what is E? E we got kq by x square. Or we can write E is equal to what is E, D? D is equal to this. So what is E? E is equal to D by E is equal to D by epsilon. So we got Q by 4 pi epsilon D by 4 pi epsilon x square dx x is equal to infinity to x minus. So from here we can get the value of, after integrating this, we got the value of minus q by 4 pi epsilon integration of 1 by x square dx. What is the integration of 1 by x square? Minus 2 plus 1. Minus 2 plus 1. Minus 2 plus 1 means it is minus 1. So we got here q by 4 pi epsilon of x to the power minus 1. X to the power of minus 1 is nothing but the x. And what is the limit? Limit is infinity to x. So x is equal to x is okay. 1 by infinity is equal to 0. 1 by infinity is equal to 0. So we got the potential V is nothing but the q by 4 pi epsilon into x. So if we get the value of the V, what is the value of the capacitance? Capacitance value we know, q by V. So if we put the value, we will get the capacitance is equal to C equals to 4 pi epsilon into x. Next important question from this chapter is capacitance of a concentric sphere. Concentric means there are two spheres, sphere 1, and we are taking the another sphere, sphere 2. Both have the same center, and we took the radius of the yellow one is B, and the radius of the green one is A. So the inner sphere is positively charged with the plus q. So if we give the charge to the inner sphere, what will happen? The positive charge will be accumulated on the outer surface of the inner sphere, and due to the inner sphere, the negative charge will be induced in the outer surface of the inner surface of the outer sphere. So what is the potential for the inner sphere? Just we calculated before, q by 4 pi epsilon A. What is VB? VB is for the negative q. So minus q by 4 pi epsilon into B. So already we in my previous lecture we have calculated the voltage calculation. So VA is equal to q by 4 pi epsilon A. VB is equal to minus q by 4 pi. So what is the total voltage? Total voltage is VA plus VB. So what is the value of VA by VB? If we take the q by 4 pi epsilon constant, we will get 1 by A minus 1 by B. So what is the value? Again we can write q by 4 pi epsilon AB B minus A. So what is capacitance? Capacitance is again C is equal to q by V, and if we put the value, we will get C is equal to 4 pi epsilon AB by B minus A. So this is the capacitance of a concentric sphere. Concentric sphere means the sphere has the same center. Now we will discuss the capacitance of a cable. So first we will think the and we can better to tell this is the concentric cable. So capacitance of a cable, how we can calculate? We know when there is a cable is there. Again, what is the how to calculate the total charge? We know that the total charge Q is equal to D dot ds. We are taking one cable whose radius is r. So what is the d dot ds? D dot ds is equal to this length is we are taking as L. So 0 to 2 pi, 0 to L, dr d phi into dz. So if we integrate this, we can get similar very easily the total surface area of the surface area of a cylinder is nothing but the 2 pi RL. So if we put the value dr, the flux density, into 2 pi r dl, we will get the value of the capacitance. So what is E? E is nothing but the E is nothing but the d by epsilon. So what is the value of D here? We got D is equal to, we got the dr or D is equal to, or we are writing D here, it is easy. D is equal to Q by 2 pi R L. So what is E? E is equal to Q by 2 pi epsilon R into L. So we got the value of E. Now if we want to calculate the voltage, what is V? V is equal to Q per length. So E into dl, we are calculating this. Q by 2 pi epsilon is constant. E into dr. E into dr means nothing. If we are calculating for one length, so it is length. So what is this? 1 by r dr. So Q by 2 pi epsilon L into 1 by r means ln into r. Now, if it is a concentric sphere, what will happen? Concentric cable, what will happen? There is one more cable is there, and their distance at the inner A is equal to the inner and B is equal to the outer surface. So, what will be the V? V will be Q by 2 pi epsilon L. What is B? Actually, B is equal to minus EDL. So, we are taking one minus. So, outer surface to inner surface. So, it will be ln B by A. Actually, this integration will be from B to A. So, if we change the integration limit, actually it is B to A. So, if we take out the minus, then what will happen? This will be A to B. And after integration, we will get Q by 2 pi epsilon L ln B by A. So what is the capacitance? Again, capacitance is equal to Q by V. So we will get 2 pi epsilon into L divided by ln B by A. So this is the capacitance for a concentric cable, or we can tell coaxial cable. We can tell the coaxial cable. For next, we will discuss about the field intensity due to a circular conductor. Say we have a circular conductor here. So we have to calculate the field intensity at a point H at the center. We are calculating the value of H at a center. Let us consider a circular conductor with the radius R. we have to calculate the magnetic field intensity. We are calculating the magnetic, this field intensity is nothing but the magnetic field intensity at the center of the circular conductor. So we can circular conductor using the Biot-Savart's law. Here we will use the Biot-Savart's law. So according to the Biot-Savart's law, dH is equal to, actually we know that always the line, it will create a 90-degree angle with the center. The radius will always create the 90-degree angle. So we can write dH, that the I into dl. So dH is equal to I dl. What is the Biot-Savart's law? Biot-Savart's law is equal to I dl sin theta by 4 pi r square. So we are writing here I dl sin 90 by 4 pi r square. We know that dl is equal, sin 90 is always 1. So we got dH is equal to I dl sin theta. So if we take the integration both sides, we will get H is equal to I by 4 pi r square integration of dl. Now for a circular path, dl means the circle. What is the meaning of the dl? dl means the circular path. So we got I by 4 pi r square into 2 pi r, the perimeter of the circle. So 2 pi, 4 pi will cancel out. R cancel out. So what we will get here? We will get here H is equal to, what is H? I by 2 into R. This is for only one circle. So if the number of circle is n time, it will be Ni by 2R. And what is the unit of H? H unit is ampere turn per meter. Now we got here H is equal to Ni by 2R. Already we discussed from the previous slide only. Now second part is we have to calculate of the field intensity due to the circular conductor at an external point. So again we have a circular conductor, so flux will go out in the all the sides. We want to calculate the field intensity at a outer point P and say that radius of this is capital R. The distance of the point P from the center is x and the distance from the perimeter of the circle is, we are taking as small r. So what is the small r? Small r is nothing but the root of x square plus capital R square. So what is x? X is the distance of the point with respect to the center. What is R? R is the radius. Now according to the Biot-Savart's law, we can write dH or H is equal to I dl sin theta by 4 pi distance square. Here I am writing smaller square. I, what is the dl here? You can see this is the dl, current carrying conductor. So we can write I r sin theta (4 pi r square). What is r? Root of x square plus r square to the power half. Now what is the meaning of the sin theta? From this figure you can see if this is the theta, this is also the theta, and sin theta is equal to capital R by smaller, capital R by smaller. So capital R by smaller, again smaller is equal to x square plus r square. So if I put the value I r square, r into r divided by 4 pi x square plus r square to the power 3 by 2. So this is the field intensity for the external point. Now we will calculate the field intensity due to the square conductor. So from the above figure, we can say that there are each side AB, BC, CD, DA, and as this is a square conductor, all the sides is the A. All the sides are in the A. So what is H? H is equal to I by 4 pi A. We will calculating the value at this middle point. So again we are using the same formula, I dl sin theta. So in every right angle triangle we will get the right angle triangle between the current element and the center. So all we are getting here is a right angle triangle. So what is this angle? As this is A, this side is also same. So this is the 45 degree. So the total magnetic field intensity at the center of the square due to all the corners using the Biot-Savart's law is, if we are thinking from this corner and this corner at a time, it is working. This is, if we are taking this triangle, what is the condition? This is A. So I by 4 pi A into sine 45 degree plus sine 45 degree. So for one right angle triangle, we got the value I by 4 pi A into sine 45 degree plus sine 45 degree. So what is, if we use the all the four sides, so how many triangles are there? 1, 2, 3 and 4. So 4 into I by 4 pi A into sine 45 degree plus sine 45 degree. Sine 45 degree is 1 by root 2. So I by 4 cancel out. So I by pi A into 2 by root 2. So we got here H is equal to root 2 I by pi A. Next, we will calculate the field intensity due to a solenoid conductor. Assume there is a small length dx. This is a solenoid. Solenoid means one bar on which the electric conductors are wound on. So what we are doing? We are taking a small length dx. Next, so if the total number of turns, if n is equal to number of turns per meter, then for this dx length, the total number of turns is n dx. Let us, so what is the magnetic field intensity at a point P? This is a point P. So we have to calculate the magnetic field intensity. So if the total number of turns is n and the total length is L, so we can write n is equal to n by L. The magnetic field intensity due to the, now we have to calculate the magnetic field intensity due to the P. So already we know dH is equal to I square by 2r cube into n dx. How we are getting? Again, I dl sin theta by 4 pi r square. So if we take it in a triangular form, we will get a triangle where r is the distance from here to here is a distance r. This is the distance r. So we will, if we put the value, r is equal to root of a square plus h square. So, and as the angle is very, very small, we can write sin theta is equal to theta is equal to a by r. So if we put all the value, we will get dH is equal to n sin theta d theta by 2. So what is dH? If we take the integration in the both side, we will get in sin theta is equal to minus cos theta by 2. So if we put the value, it is a triangle. So from 0 to 2 pi, H is equal to Ni by L. So what is the H? H is equal to, in the midpoint, the H is equal to Ni into 2L. So already I have discussed about all the field intensity problem. So this is the some important derivations, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.